Hello everyone, welcome to YouTube channel Energy-Exergy Theory Applications. I am Professor Tatiana Morosuk and I am the author of this YouTube channel. Today we are with the topic exergy. All lectures have a very dynamic style of presentation. Definitely some of you would like to learn more, particularly about exergy. We will be happy to answer your questions and provide with an extended information. Our contact email you can find in the description of each video. Please support our work with a like to this video, subscribe the channel and share the link with your colleagues. Lecture 2 in the block exergy. Today we continue to discuss the concept of exergy and our topic is components of exergy. I repeat the definitions. As you probably remember, we have 4 definitions for exergy. These definitions are not alternative. It is one definition support to other. So first of all, exergy is the combination of quantity and quality of energy. And also exergy, it is the measure of the deviation of the state of the system that we would like to calculate exergy from the state of thermodynamic environment. So again, I would like to remind you that within exergy, we will continuously refer to thermodynamic environment, but not natural environment. Okay, if we discuss about energy, please remember energy. In thermodynamics, it is the sum of internal energy, kinetic energy, and potential energy. And if we would like to give the value of exergy to these 3 kinds of energy, we need to discuss quantity and quality. Actually, quantity we know, we need to introduce the concept of quality of these 3 kinds of energy, 3 contributors to energy. And we will discuss hypothetical engine and the work that can be generated within this hypothetical engine, it is exergy. So it means that in order to calculate exergy, we need to calculate hypothetical work. So all equations that we know for calculation of work from classical thermodynamics, we can use in exergy, in concept of exergy, to calculate the value of exergy. So one more time, we always will discuss system and thermodynamic environment. Exergy is an extensive property of the system. So we will introduce a new property of the system, which is called exergy. Before we introduce it enthalpy, we introduce it entropy, now is the exergy. And exergy, it is the work, it is equivalent to work, therefore the units of exergy also joule, similar to work. Using a macroscopic approach in thermodynamics, we can discuss that exergy of the system consists of 4 contributors: chemical exergy, physical exergy, kinetic exergy, and potential exergy. And we need to calculate all 4 terms, and some of these 4 terms will be exergy of the system, but not vice versa. We will not calculate exergy of the system and after that divide into terms. No, it is only one way of calculations of exergy. And since exergy it is intensive property, we can calculate specific exergy, of course, on the mass base or on molar base. Volume base is not very popular in exergy analysis, but also volume base is possible because exergy, I will repeat, it is extensive. For scientists who are working with microthermodynamics, with statistical thermodynamics, exergy analysis is also possible to apply. Then we need to calculate additional terms of exergy. It is nuclear exergy, magnetic exergy, electrical exergy, and surface tension effect, exergy of this effect. Microthermodynamics for exergy analysis is not very popular, this approach in exergy analysis, and calculations of these terms of exergy associated with microthermodynamics can be found in the publications of end of 60s and beginning of 70s, because when exergy concept was established and it was very interesting to apply this concept for different tasks. We will focus in our lectures only on macroscopic approach. So let us start with kinetic and potential. Energy and exergy. We already learned in the previous lecture that kinetic, potential, mechanical, and electric energy can be fully converted to any other form of energy if we have possibility to realize the ideal process, ideal conversion process. So let us start with a very understandable example. We will try to generate work using, for example, the flow of water. So we will convert the potential energy of water to the mechanical work. In this way, equation for energy and equation for exergy will be the same. And the more work we can generate, only if we will have the higher elevation. So the state, the difference between state of the system and state of the environment. For potential energy, it is the elevation. Another example, we will convert kinetic energy also of stream of water, and we will generate work. So how much work we can generate depends on the velocity of this stream. The higher velocity, the more work we can generate, means the higher exergy will be. So this is simple examples from the conversion of potential and kinetic energy of water to generate work. I think it is very clear. And now we will go to abstract level of exergy analysis. Now we need to discuss the kinetic and potential work associated, for example, with airplane. Definitely, airplane cannot be expanded in order to produce work. This is absolutely clear. Therefore, kinetic and potential exergy, it is the states to describe the system, which is our airplane. State 0 we will fix with the airport, and then airplane will have kinetic and potential energy. Kinetic energy will associate with the speed of airplane, and potential energy associate with the elevation of the flight for this airplane. And now flexibilities of exergy analysis. We know that in exergy analysis, very often, effects of kinetic and potential exergy are negligible. Negligible means that we will not say that they are zero. They are not zero, but we know that they exist, but it is not useful for us to calculate these values and just to generate many numbers, and it will not help our understanding of the process and evaluation. Therefore, we will simply neglect these effects, and we will focus only on physical and chemical exergy. How to understand the moment that we will neglect the effect? Again, this is our airplane, and we would like to evaluate airplane. Then definitely airplane will be the system. We will introduce boundary condition for the entire airplane, and we will calculate kinetic and potential exergy. Let us assume that next task, I don't want to evaluate the entire airplane. My interest, it is only gas turbine system of the airplane. Then I can change conditions of analysis. I can say that state 0 will fly together with the airplane. Then definitely airplane will have kinetic and potential exergies, but this exergy we will not calculate because it is not relevant for us for our analysis. And in order to evaluate engine, we will discuss only physical and chemical exergy. So now you can see that exergy analysis has quite a lot of flexibility to neglect one effect and focus only on effects that are important for our analysis. And this we can do with the changing of the state 0, or better to say, with correct selection and fixing of state 0, which is thermodynamic environment. Let us continue with the forms of exergy. So energy, it is internal energy plus kinetic energy plus potential energy. And we just learned that kinetic and potential energy and exergy, it is the same value and the same meaning. But internal energy has no term in exergy. This term for exergy, it is physical and chemical exergy. In order to, first of all, calculate chemical and physical exergy, but also to understand the meaning of physical and chemical exergy, we will continue to use hypothetical engine, and the work that will be generated by this engine, it will be physical or chemical or together. Exergy depends on what means, how we will describe thermodynamic environment, because system is system. This is clear. So let us repeat that exergy is the maximum theoretical work theoretical maximum work that can be obtained from the system when system will be brought to the equilibrium with the environment. Now we will really discuss hypothetical heat engine, and we have hot reservoir, we have a cold reservoir, and work that will be produced, it is the exergy. And we know how to define the efficiency of this system. It is the second law of thermodynamics. It is maximum work that can be produced over driving energy that should be supplied, it is Q hot. And if we discuss maximum theoretical work, definitely Carnot cycle should be realized. And for the Carnot cycle, efficiency depends only on temperature of heat source and heat sink. This we already know from engineering thermodynamics. We can rewrite this equation and calculate the value of work. Then it will be heat supply to the system and efficiency of the system. This is absolutely clear. Now let us use these definitions for exergy analysis. Work, it is exergy. Quantity of heat, we know it is Q hot. And quality of heat associated with the maximum efficiency that we can calculate for the Carnot cycle when we know the temperature. This efficiency, Carnot efficiency in exergy analysis is called Carnot factor and will describe for us quality of heat. So exergy, it is quantity and quality of heat. Now we're discussing about the heat. And example, if we have three systems and thermodynamic environment, absolute clear that system 1 and system 2, they have the same quantity but different quality because they are with different distance from the environment, means with different temperature. And system 2 and system 3, they have different quantity because amount of heat is different, but quality is the same because both systems with the same temperature. This is simple explanation of exergy of heat as combination of quantity and quality. Let us proceed with the exergy of cold. Sometimes it's called like that, or better to say with heat that is a temperature level below of environmental thermodynamic environment. Then we have alternative definition, and exergy, it is minimum theoretical work that required to supply to the system, to bring system to the full equilibrium to the thermodynamic environment, but from the lower level to the higher temperature level. And equations will be absolute the same as for a previous case, but now please follow all changes that should be, so all adjustments that should be done in these equations. Instead of maximum work, we will write minimum work. Instead of Q hot, now we would like to calculate exergy of Q cold, of below the environment. We will change to Q cold, and instead of T hot, we will introduce the temperature that our system is under this temperature below the environment. We will put T cold. Then, as you can see, equation will be the same, just with different temperatures. Depends on exergy of which quality of heat, I mean below of the environment or higher than environment, we would like to evaluate. Definitely Carnot factor will be negative and exergy will be negative. But we already discussed it from the beginning that for processes below of the environment, exergy, it is the work that should be supplied to the system but not produced by the system. Therefore, logically, it's absolutely correct that this value will be negative. This negative sign, it is only indication that heat at the temperature below of the environment. For all calculations, we can use absolute number and we can ignore that it is negative because we know that T cold is lower than T of the environment, I mean thermodynamic environment. And using these discussions one more time, we will repeat Kelvin Planck statement that it is impossible to produce work if we will have two thermal reservoirs with the same temperature. So it's the second law of thermodynamics. Now we will apply it for exergy analysis. So it is impossible to produce work if thermal reservoir will be with the temperature of the environment. What it means for us? That exergy of thermodynamic environment is equal to zero, because we cannot produce work. Work is zero, exergy zero. So this is a link between exergy analysis and all our discussions related to the first and the second law of thermodynamics. And this is a very popular figure to discuss the components of exergy. So we have thermodynamic environment in a gray color, and let us assume that this value exergy of system we need to calculate. First, it is exergy associated with kinetic and potential energy. After that, we will calculate the term which is called physical exergy, and the last we will calculate the term which is called chemical exergy. It means that all these four contributors can be calculated independently, but very important, under which conditions we will calculate these values. So for each condition we need to discuss state zero. For kinetic and potential energy it will be ground, not moved system, underground. For physical exergy and for chemical exergy, we need always defined thermodynamic environment. And at the end of this video, I would like you to give a like to this video. You will support us with your like, subscribe the channel, and share the link with your colleagues. Our next lecture, lecture 3 in the block exergy, will be dedicated to detailed discussions on physical exergy. Thank you.